Hello everyone, my name is Pushi Tripathi and me along with my group mates are going to present on the topic stroke prediction. For these presentation, we'll have a project and data set overview, the project objective, the techniques we have used for this project, exploratory data analysis where we visualize our data with the help of three models. Then we explain how we built a model and compare the results of these models and conclude the result of the dataset. The project and dataset overview. Here, this project is about to predict the likelihood of a patient suffering from a stroke based on input parameters of the dataset. We have taken this dataset from Kaggle, and this dataset consists of more than 5,000 rows and has 11 columns like gender, age, etc. For this project, we will be using three models: logistic regression, random forest, and boosted trees. Project objective. Stroke is one of the major causes of death and causes significant health like issues, for example, emotional and physical issues, as well as financial burdens for both patients and the healthcare system. One of the important risk factors for stroke is health related and patient history, which is becoming an increasingly important focus for the prevention of heart stroke. The aim of this project was to apply computational methods or machine learning techniques to predict stroke from lab test results from a series of data collected by multiple patients. We use different models and make comparison based on the best results we get from each model. For this project, the techniques we have used are: we use Tidy Models library for model fitting, which means we process we pre-process data and have results validation. We use SkimR to provide summary statistics and variables for the data set. We use logistic regression and build a model, find the error of the data set. We use random forest as well for the same thing. We use boosted trees method and then we compare the above three models. The next part will be explained by Vinay.
Hi, this is Vinay. Now I'll continue from where Kushi left. Okay. First, let me explain about the data set. The data is taken from Kaggle website. This data set has 5,110 rows and 11 columns. And this consists of features of gender, age, work type, residence type, uh, heart disease, average glucose level, BMI level, which means body mass index, hypertension, and ever married, and also the smoking status. But the target column will be the stroke. All the features of this data set have been used for training the model except the ID. Okay, now we will look into data set pre-processing. This is the main step here, and this data set contains 201 null values in BMI attribute. Okay, so these null values are replaced by calculating the mean value of remaining BMI values. So we'll calculate the average or mean of the remaining BMI values, and that will be replaced by those null values will be replaced by the mean of the BMI values. And also we converted the features such as gender, ever married, work type, resident type, smoking features into numeric. So here we'll convert them into numeric so that the machine can read values in machine readable form. So, and the other attributes such as average glucose level and BMI data are first normalized, which means it changes the values of numeric columns to a common scale between 0 and 1. So now the data set is split into 80 to 20 ratio. So the 80% of the data we used for training and the remaining 20% of the data we use for testing. Now we will see the analysis of this graph, okay, exploratory data analysis. From this analysis, we got the output as the people who are having the age limit from 40 to 80 are having high chances of getting the heart stroke. So this means when the age is increasing, the chance of getting heart stroke is also increasing. we got analysis from this graph. So if we look at this graph, we can clearly understand that when the age is increasing, the chance of getting the heart stroke is also increasing. Next slide. Here we are taking attribute as hypertension, which is nothing but blood pressure. Okay, we have done analysis here. So the person who is having the hypertension has high chance of getting the stroke. So from this analysis, we can see person is getting stroke if he is having hypertension. There is a more chance of getting the stroke than the person who is not having the hypertension. So this attribute we concluded with this. So that can be understood by seeing those two graphs. Okay, next slide. And now here we are taking attribute as heart disease. So person who is having heart disease has high chances of getting the stroke than the person who is not having the heart disease, because this attribute plays a key role. So persons who are having the heart disease are more likely to get the stroke. So remaining attributes also plays a key role, but this is the major attribute which we are taking. And next slide. So this is one more attribute which we took, that is smoke. So people who smoke also have a chance of getting the stroke, but here from this graph, we are having the see the graph level is high for those who don't smoke. So the first one is formerly smoked and second one is never smoked. See, the second bar is showing the highest because neverly smoked is getting highest. So from this graph, we can see that formerly smoked and smoke are likely to get heart stroke, and that we can see never smoked is very high in both the graphs. This may be due to other causes. There may be other causes such as radiation or passive smoke, etc. So this we can't decide by single attribute. We have to take multiple attributes to decide about this stroke. And now we'll see the models which will be explained by my teammate Sai.
Hi, my name is Sai, and I'm going to cover the models that we have used in stroke prediction. Uh, we have used three models: logistic regression, random forest, and the boosting trees. Firstly, we have used logistic regression to find the value stroke, which is the target. So, regression is an algorithm used widely in statistics and machine learning. Logistic regression is basically similar to linear regression, which predicts the value of the model, whereas the logistic regression predicts the values like yes or no type of response. Yeah, in this model, we have used average age, and average glucose level, and heart disease, hypertension, and BMI, and our married as an independent variable to predict the value of target, that is which is stroke. As we can see, the model identifies that BMI are BMI and our married are less significant in finding the values of uh, target value stroke. Next slide. And the next model that we have used is a random forest model. And in this model, random forest is basically is a training a group of many decision tree classifier, each on different random set of data set to make a prediction. We just obtain the predictions of all individual trees, then predict the class that gets the most votes. In this, we have used thousand decision trees, and we used shrinkage as 0.7, which has shown a significant effort in getting the value of stroke. Mm, And next thing we have used is next slide. And next model we have used is boosting tree model, where we used uh, boosting tree is similar to random forest, but here we take lot of weak predictors and weigh them, add them up, and get a single strong predictor. Here we have used random decision trees, and shrinkage to 0.7, and we used distribution as AdaBoost, which is widely used in classifying the data. And okay, next slide. And we can see the errors of each model in this table, where we got logistic regression has 5.23 and random forest as 0.041 and boosting trees as 0.043. We can clearly see that random forest has uh, done good work on the data and given less error for the model. Next slide. And this is the graph of the errors of the model, that is logistic regression, random forest, and boosting trees. As we can see that random forest has done good work in finding the target stock. Next slide. From the from all the graphs and model comparison, we can say that random forest method performed best for this better data. However, there was not much difference in the error of random forest and boosting tree methods. We can also infer that lifestyle is poor predictors of stroke. In order to get better performing model, we need more data related to psychology, biochemistry, or genetic patients. Thank you.